Very good morning or a very good day to all the students. Now we are going to discuss about class-based modeling. In our previous lecture, we have seen what is a scenario-based modeling, and we have actually discussed three type of diagrams that falls under scenario-based modeling. That is use case diagrams and how we transform a particular use case from the use case view to an activity view using activity diagram, and then what is the need of a swim lane diagram when we have an activity diagram. So we have seen these diagrams used in the preview of scenario based modeling. Now the next thing is class based modeling. A class based modeling represents the objects that the system must manipulate. First of all, classes, when we think of classes, the classes are visualized with the help of objects and some operations. The operations are so called as methods or services that will be applied to the objects to affect the manipulation. The relationships between the objects and the collaborations that occur between classes that are defined. So these are the four class-based modeling concepts that needs to be understood, that what are objects, what are the operations, what are the relationships, and what are the collaborations. The elements of class-based model include classes, objects, attributes, operations, CRC models, collaboration diagrams, and packages. So in this video series, we are not going to cover packages, but rest of the things we are going to see what they mean. Okay. So though the second, now let us understand the class-based modeling with the help of more detailed system. Now, classes are determined by underlining each noun or noun phrase and entering it into a simple table. So, how do you find a class? You find a class in a particular system using the word called noun. Okay, you can find it with the help of nouns, right? Or noun phrase, the phrase that contains the noun. Okay, this is what you do. So we will see some examples also in the next slide, but as of now understand that these nouns actually tells you about the classes. A class should never be an imperative procedural name. So, for example, if the developers of a software for a medical imaging system defines an object with the name invert image or even image inversion, is it correct? Question is this, and this is the question for the viewers to answer. So you can answer this question, and I will love to see the answers also in the comment box if you answer this, that whether this developer can name an object with the word with the can give a name for invert image or even image inversion. If not, why? If yes, okay. But if you are saying yes, you should give some reason. If you are saying no, you should also give some reasons. Okay. Now the next thing is each class can be divided, can fall into various type of classes. Okay, and that are known as analysis classes. So analysis class means if I find nouns, I can put that noun into several different type of classes. Okay, the thing is, the class can be an external entity. That means that produces or consumes an information to be used by a computer system, like an actor. Okay, an actor generally is the external entity. We have seen this. So a class can be an actor, like homeowner is a class. That can sensors can be a class. The second thing is that class can be a thing. That means a report or display or letters or signals that are part of the information domain for the problem. It can also an occurrence or an event. That means it can be something related to time. That means that occurs within the context of a system operations. That means whenever a certain operation happens, this class should invoke. Until unless that event occurs, the system that class should not be invoked. It can also be a set of roles like manager or like the homeowner is also a role, right? A manager, engineer, salesperson, played by people who interact with the system. It can also be an organizational unit. That means it can be a division or a group or a team that are relevant to an application. Suppose in a system of education that we are in right now, there can be a group of faculty members. You can be a faculty or you can be a student, but if you are a student, you can be an undergraduate student, you can be a postgraduate student, you can be a research scholar. Okay, likewise if you are a faculty, you can be a professor, you can be an associate professor, or you can be an assistant professor. Okay, what will happen if a faculty is being is selected as a first time as an assistant professor, right? He enters his details in his CV, in his web page, right? Now what happens, he is now promoted to the role of associate professor. The details will will he have to add all the details now again into the profile, suppose somewhere else? No. What we can do, we can move this particular data from this organization unit to this organization unit. Okay, so by pulling it, this can be one class, this can be another class. Okay, assistant professor is one class, associate professor is also another class. Likewise, the class can be places, that means a manufacturing floor or a loading dock, that establish the context of the problem and overall function of the system. It can be structures like sensors, four-wheeled vehicles, or computers. Okay, like objects that define a class object or related classes of the objects. So you are having certain set of classes, 1, 2, 3, 4, 5, 6, and 7. So there are 7 analysis classes that each class that you identify can fall in, right? Now based on these set of classes, you can also see that there can be multiple. This is the analysis. Okay, now actually whether the class falls under any one of them or not, whether I can call them a class, is called as a potential class. Okay, now let us see some examples. Let's see an example of how to find a class. So this is an example of a safe home security function that enables the homeowner to configure the security system with, when it installed, monitors and all sensor connected to a security system, and interact with the homeowner through the internet or an PC or a control system. So this is the complete description of a homeowner system or security system, in which the nouns are underlined, in which these nouns are underlined and the verbs are italicized. That means this homeowner is a class, right? Configure is not a class, it is a relationship. Okay. Now homeowner relationship with sensors is homeowner can configure the sensors. Okay, homeowner can install the sensors, homeowner can monitor the sensors. So this is the relationship between the homeowner and the sensor class. Likewise, sensors are connected to and interact with the homeowner through the internet. Sensors are related to the internet or the control panel using a relationship that interacts, right? So you have multiple classes. Whenever you want to find classes, you underline the nouns, and when you want to see the relationship between the classes, you have to italicize, or you have to use a different method to find out the relation between the classes. Okay. Now based on this, there are the classes that we actually analyzed, right, are categorized now into potential classes, right? Like homeowner, the homeowner can be a homeowner can fall under the classification of a role or an external entity, right? Homeowner can be a role, homeowner can be a someone who actually access the system. Like sensors generally are external entity. Control panel is an external entry that provides input to the system. Installation is an occurrence that will occur at a particular instance of time. Once the instance is installed, this installation class will not occur again. Okay. Likewise, master password is a thing, sensor event is an occurrence, right? Now this thing what is known as number and type, it is actually it is actually not an object, it's an attribute to sensors. So what we can say, when this type of data comes in, like number and type, they cannot be like put into classes. What we do, we assign them as an attribute to another class, which more meaningful. Okay. Now based on these type of potential classes that we identified, we out of these all classes that we identified in a particular paragraph, using underlining a noun, we now go and check whether the class whether each class has certain characteristics. If that class that we have identified as a potential class has those characteristics, right, then we will say that this class is now considered as a class in my further diagrams. Otherwise we will not take that as a class in my further diagram. So what are the characteristics that makes the potential class an actual class? They are the six characteristics that actually that should be used to consider each potential class for the inclusion of the in the analysis model. That this analysis model will be taken in the design phase, right? In the design phase. So we can select one all the potential class. We have to see all the classes that we have identified for the set of data. Okay. The first thing is it is called as retention. That class should actually retain certain information, right? It should retain certain information. Secondly, it is a needed service. The potential class must have a set of identifiable operations. Oh, I missed P here. It will have certain set of operations, right? Operations that can change the value of its attributes in some way. The third thing is it should have a multiple attributes. During requirement analysis, the focus should be on measure of information. A class must, with a single attribute, in fact be useful during design phase, but is probably better represented as an attribute to another class during the analysis activity. So generally we don't take a class with a single attribute as a class. Okay, we don't use a class. The next thing is it should have some common attributes. A set of attributes can be defined for a particular class, and these attributes apply to all instances of the class. For example, there is something called a class called student. A student might have a enrollment number. Okay, it can have a faculty number. It can have a attribute called branch. It can have an attribute called CPI, suppose, and it can have an attributes. These four attributes, right? Now the class attributes are so general that it applies to the complete set of students that belongs to either UG, PG, or maybe postdoctoral or doctoral or research. So these attributes are common attributes, right? So I can take this class of student as a class itself in this sense. The next thing is called common operations. Common operations means a set of operations that can be defined on a partition class, and these operations can be applied on the instances of all the class. So suppose students have operation of result processing, or it can have an operation of CPI conversion. So these operations are totally defined on an object on a single instance, and it can be extended to all the instances of that particular class. Now lastly, it should have essential requirements. External entities that appear in the problem space and produce or consume information essential to the operations of any solution for the system will almost always be defined as a class in the requirement model. Or there is something which is utmost required is a part of the, without these the analysis model will not be complete. So these things will be a part of the classes. So to be considered a legitimate class for inclusion in the requirement model, a potential object should satisfy all or almost all these characteristics. So there are 6 characteristics. So for a class to be a part of the inclusion model, that means it should have almost either 6 of them or at least 5 of them. Okay, so this was another exercise for that was given to the students, that is given to students, and this is actually given in Roger Pressman, and this class tells you about this thing tells you about this is it is they have given in a it is in a tabular form. Just you have to go in on the book in the chapter, and you to find out whether a homeowner satisfies these 6 characteristics or not that we have studied. Homeowners, if it is satisfies, say suppose this is number 1, this is number 1, and this is number 2, this number 3, then going ahead to next one. So it can be number 4, common attributes, then it can also be number 5 can be the other attributes. Okay, so you can actually see this here. So it can be number 4, number 5, and number 6. So in this, now what will you do? You have what sorry so what you need to do is you need to actually start you need to actually what you do, you have to number that particular system, right? You have to number them up here, right? You need to number them up here, like you can write it in form of 1, 2, 3. So if I write it here, suppose homeowner numbers that applies, so I say 1, 2, 3, 4, 5, right? So I can say except. So suppose I have a type called number and type, it only has 1 and 2, suppose, then this will be reject. In this fashion you have to fill this up, right? And you identify the set of potential classes. Okay, now coming to the next topic, like how to identify or specify an attribute in a class diagram or a class-based system. Attributes describes a class that has been selected for inclusion in the requirement model. So it is the attribute that defines a class. Okay, that clarify what it is meant by the class in the context of the problem space. Sensors are part of the overall safe home soft system, yet they are not listed as a data item as an attribute. Sensors actually are important thing in a safe home based system that we have seen in the previous example, but they are not part of a data item. Why? Because multiple sensors objects are issued with the same system class, and sensors have already been identified as a class. So when we have a class called sensors, I cannot include the sensors as a attribute or a data value for some other class. Okay. Now operations, on the other hand, are the behavior of an object. Okay. Now operation can be defined into 4 broad categories. First of the operations that manipulate the data in some way, like adding, deleting, reformatting, selecting. These are the operations that we can do as a part of data manipulation. Then next, what we can do, we can have operations that perform certain computations, right? The next thing is the operation that can inquire about the state of an object, and finally operation that monitor an object or for the occurrence or a controlling event, right? An operation must have knowledge of the nature of the class, attributes, and associations. So in order to do these type of roles or this type of work, the operation must have some knowledge about the class itself. It should also have the knowledge about the attributes and the associations that the class have with another class. So defining an operations, say that if I have example here, sensor is assigned a number and a type. So what I am doing here is I have a class called sensor, right? I have a class called sensor, and this is an italicized word. It says that this is an operation, right? Assign is an operation that works on the class called sensor, right? Likewise, program or arm or disarm are the operations that actually applies to the system class, and it uses the master password as a thing, right? So with the help of the master password, you can program also, you can arm also, and you can disarm also. Arm and disarm means enabling and disabling of the system. So there should be there should be a logic given in the control panel, that with the help of that you can either enable or disable a system. Okay. So arm and disarm are the operations that apply to the system class, and assign is an operation that is assigned to a sensor class. This is a diagram of a general diagram of class, a general class diagram, and it has three sections. Okay, the first section tells you about the class name. So this is the class name, this is system. The second section is called the operations, yeah, attributes. Sorry, attributes that the class actually uses for its working, and these are the set of operations that a class implements, right? Or you can say methods that the class implements. So the class diagram has three sections. One is the class name, second is the attributes, and third is the operations. Now each class actually cannot do the work by itself, right? So that class needs another class for its working, completing its role, right? So in that case, what we can do, we actually need to understand another concept which is known as collaborations, right? Then we have something called CRC, class responsibility collaborators. So we will see this in the next lecture, what are CRCs and how we can define different type of relationships based on the CRC model. Thank you very much.